In the previous lecture, you have learned about magnetic field and magnetic force. From my last explanation, I have delivered to you how to calculate the magnetic force on a charge moving in a magnetic field. The formulation to calculate the magnetic force on a charge moving in the presence of magnetic field can be described as follows. FB is equal to Q V cross B, where FB is the magnetic force, Q is the charge, V is the velocity of the moving charge, and B is the magnetic field. The next thing that I want to deliver to you is about how to calculate magnetic force on a conducting wire. From the previous study, you have known already how to calculate the magnetic force on a single moving charge Q. The magnetic force on a single moving charge is equal to QVB sine theta, or you can also know this magnetic force as a Lorentz force. So next, how to calculate the magnetic force on some amount of moving charge through a conducting wire. So on the other word, we can say how is the magnetic force on a conducting wire which contains some moving charges. We know that the moving charges is the same as current or I. From the previous formulation, we have that the magnetic force is equal to QVB sine theta. Delta Q here represent that this system contains some amount of charges. If we multiply this formulation with delta T over delta T, so finally we have magnetic force we can modify to be delta Q over delta T times V delta T B sine theta. If I demonstrate this condition, so I put a picture here in the left side. So the conducting wire here with the length of L, and through this conducting wire there is a current flow through this conducting wire, and we know here that delta Q over delta T is equal to I, or current, and V times delta T is the same as the length of the conducting wire. So the velocity of a charge within times delta T is the same as the length of the wire, of the total distance, or the total distance of the charge. So finally, we can find that the magnetic force on a wire is equal to ILB sine theta, or we can also describe the magnetic force on a conducting wire as IL cross B. So until this stage, you know already how to calculate the magnitude of the magnetic force. And then the next thing, you know that the magnetic force is a vector quantity. So besides the magnitude, you also need to know how is the direction. The direction of the magnetic force can be determined by the right-hand rule. So here, the way to determine the direction of the magnetic force is right hand rule 1. So we name this as right hand rule 1 because later we will have right hand rule 2. So in the case of right hand rule 1, we can determine the direction of the magnetic force. So just using your right hand, each finger can represent each parameter. So in here, your thumb can represent the direction of the current, and your 4 other fingers can represent the direction of the magnetic field. And finally, the magnetic force, the direction of the magnetic force is perpendicular to the palm of your hand, like this. So it's quite easy how to determine the direction of the magnetic force using right hand rule. Okay, so from this explanation, you already know how to calculate the magnitude of the magnetic force on a conducting wire together with the direction of that magnetic force.